I see this option. Increasing alpha strengthens regularization in ridge regression. Think of alpha as a dial controlling how much we pull back on the model's complexity. A higher alpha means a stronger pull, preventing overfitting by forcing the model's coefficients, the numbers that determine the impact of each feature, to be closer to zero. This makes the model simpler and more resistant to noise in the training data, improving its performance on new data. It's like adding a penalty for complicated solutions. Here, we're doing the opposite. Lowering alpha weakens the penalty on complex models. The model can then fit the training data more closely, but it might not generalize well to new data, overfitting. Imagine trying to fit a curve perfectly to a few points. If you let the curve wiggle too much, it may not capture the general pattern. That's overfitting. This would be a bad idea. Adding more features increases the model's complexity. A more complex model is more likely to capture the noise within the training data, and it's better suited to predict the training data. Consequently, its performance on unseen data decreases. It's like trying to solve a puzzle with too many pieces. You might fit some perfectly, but the bigger picture becomes unclear. This isn't a good strategy to prevent overfitting. Cross-validation helps me find the best alpha value without relying on a single train test split. I split my data into multiple parts, training the model on some and testing on the rest. I repeat this several times, rotating the train in test sets. This gives me a more reliable estimate of how well my model generalizes. It's a bit like running multiple experiments to see what works best. This is a great way to avoid overfitting. This is the main question. I need to choose the actions that prevent a ridge regression model from overfitting the training data, learning the noise instead of the underlying patterns. Overfitting makes my model perform poorly on new data, so I'm looking for ways to improve generalization. This isn't directly related to the immediate problem, but it's a valuable concept. Model selection is choosing the best model from a set of candidates. In this case, I am choosing the best alpha value, using cross-validation to make the right choice. We're tackling the challenge of overfitting in a ridge regression model. Overfitting happens when your model learns the training data too well, performing great on the data it's seen but poorly on new, unseen data. Ridge regression aims to prevent this. I see a problem here. A ridge regression model, despite performing well on training data, as measured by R², might still overfit. This means it's not generalizing well to new data. We need to adjust the model to predict accurately on unseen data. Let's find solutions. I'm looking for ways to improve the model's ability to handle unseen data, thereby reducing overfitting. This is critical for building robust models. Increasing alpha strengthens regularization, a technique that helps prevent overfitting by penalizing large coefficients. It shrinks these coefficients towards zero, making the model less complex and less prone to fitting noise in the training data. Decreasing alpha weakens regularization. This pushes the model closer to ordinary least squares, making it more vulnerable to overfitting, particularly with noisy or correlated data. Think of it as giving the model too much freedom to memorize the training set. Adding more features increases complexity, potentially causing overfitting. It's like giving the model more chances to overlearn the training data and not generalize well to new examples. Instead, we need to select the most relevant features. Cross-validation is a powerful technique to find the best alpha value, which balances the trade-off between bias and variance in the model. It involves splitting the data into multiple subsets, training on some, and testing on others, providing a more robust estimate of model performance. It helps us ensure the model isn't just memorizing training data. This is a multiple-choice question that tests my understanding of overfitting, ridge regression, and strategies to improve model generalization. I'm trying to predict house prices using a ridge regression model in Sklearn. I've got a good R² score on my training data, but I'm worried about overfitting, meaning my model performs great on the data it's trained on, but poorly on new, unseen data. I need to figure out how to improve its performance on data it hasn't seen before. This option suggests increasing the alpha value. In ridge regression, alpha controls the strength of the penalty applied to the model's coefficients. A larger alpha shrinks the coefficients towards zero, making the model simpler and less prone to overfitting. I'm thinking this might help. Lowering the alpha value would weaken the regularization. The model would be more flexible, potentially leading to overfitting as it'd be more sensitive to the training data's noise. This is probably not the right choice. Adding more features sounds counterintuitive. A more complex model with too many features can easily overfit. I need to focus on relevant features, not just add more. This is incorrect. Cross-validation is a great way to find the best alpha value. It involves splitting the data, training the model on some parts and testing it on the others. This helps me find an alpha that generalizes well, preventing overfitting and selecting the best alpha. This is a good idea. The best approaches to mitigate overfitting are increasing the alpha parameter and using cross-validation to find the optimal alpha. These are options A and D. I'm tackling the challenge of overfitting in a ridge regression model. Overfitting happens when your model learns the training data too well, performing great on that data but poorly on new, unseen data. Ridge regression, a type of linear regression, helps address this by adding a penalty to the model's complexity, preventing it from fitting the training data too closely. We'll see how we can fine-tune this to get the best results. I'm predicting house prices using a ridge regression model in Sklearn. Although the model performs well on the training data, as measured by the R-squared score, I'm worried it might overfit. That means it's doing great on the training data it's already seen, but could fail on new house data. The goal is to find ways to improve its performance on unseen data. I need to identify which actions help reduce overfitting in my ridge regression model. This means choosing strategies that make the model generalize better to unseen data. The quiz gives options that will help reduce the chances of overfitting. Increasing the alpha hyperparameter in ridge regression strengthens the regularization. Think of alpha as a dial controlling how much the model penalizes large coefficients. A higher alpha shrinks these coefficients towards zero, simplifying the model and making it less likely to overfit. Decreasing alpha weakens the regularization. This lets the model fit the training data more closely, increasing the risk of overfitting. It's like loosening the reins, giving the model more freedom, which might not be what you want if overfitting is a concern. Adding more features can actually worsen overfitting. A model with too many features might start to capture noise in the training data instead of the underlying patterns. It's like trying to explain a simple concept with an overly complicated explanation. The added information might be counterproductive. Cross-validation is a powerful technique for finding the best alpha value. I split my data into multiple sets. I train the model on some sets and test it on others. This gives a more reliable estimate of how well the model will perform on unseen data, helping me avoid overfitting to a particular training set. It's a really smart way to prevent overfitting. I see a problem here. We're using ridge regression to predict house prices, and although the model performs well on the training data, I'm worried it might not generalize well to new, unseen data, meaning, it might overfit. Overfitting happens when a model learns the training data too well, including the noise, and therefore doesn't perform well on new data. This question asks you to identify the techniques that prevent overfitting in ridge regression. I need to understand how ridge regression works and how its hyperparameter, alpha, impacts overfitting. Increasing alpha strengthens regularization in ridge regression. Think of it like this. A higher alpha adds a stronger penalty to large coefficients, essentially forcing the model to find a simpler solution that is less prone to overfitting. It's like adding a governor to a machine. I'm controlling the model's enthusiasm to fit the training data too closely. This is a good approach. Lowering alpha weakens the regularization. This lets the model's coefficients become larger, potentially allowing it to fit the training data too well. This leads to higher risk of overfitting. It's like taking off the governor, letting the machine run wild. This isn't a great idea. Adding more features without careful consideration increases model complexity, and therefore chances of overfitting. It is like giving the model more and more details without properly validating their relevance. I'm giving the model more chances to overfit. This is incorrect. Cross-validation is a powerful technique to find the optimal alpha value. We split the data into multiple subsets. I train the model on some subsets and validate it on the remaining subsets. This helps me to find the alpha that generalizes best to unseen data, minimizing overfitting risk. This is a very smart move. This section introduces the core concept. We're tackling overfitting in ridge regression. It sets the stage for understanding how to improve a model's ability to generalize to new, unseen data by carefully adjusting the model's parameters. Think of it as teaching your model to be adaptable and not just memorize the training examples. The problem statement presents a scenario. You built a house price prediction model using ridge regression, and it's doing great on the data it was trained on. But, will it perform well with new houses? This is the core question, highlighting the risk of overfitting. Overfitting is when a model learns the training data too well, including the noise, and performs poorly on new, unseen data. This is the central question of the quiz. We'll investigate several strategies to improve the model's ability to predict house prices accurately for houses it hasn't seen during training. We need to find the best way to prevent the model from becoming too specialized to the training data. This option explores increasing the regularization strength. Alpha controls the penalty for large coefficients in the model. Increasing alpha means we're penalizing large coefficients more heavily and thus encouraging a simpler model, which is less prone to overfitting. This improves the model's ability to generalize to unseen data. This option looks at reducing regularization strength. A smaller alpha means less penalty on large coefficients. This might lead to a more complex model that overfits. Because the model is free to fit the training data more closely, including any noise or irregularities. Adding more features might seem helpful, but it can increase the model's complexity. A more complex model is more likely to overfit. By learning details that are specific to the training data, cross-validation is a technique to find the best alpha value without overfitting to a single train test split. It helps us find the value of alpha that provides the best balance between bias and variance. This leads to a model that generalizes well to unseen data. We're tackling a common machine learning problem: overfitting in a ridge regression model. Think of it like this. You're trying to fit a curvy line through a bunch of scattered points. If you make the line too curvy, it'll follow every single point perfectly, but it won't predict new points well. That's overfitting. Ridge regression helps avoid this by controlling the curve's curviness. I'm using scikit-learn's ridge regression to predict house prices. My model looks great on the data I used to train it, but I'm worried it won't do well on new houses I haven't seen before. That's the overfitting problem. I need to improve its ability to generalize to unseen data. I'm looking for ways to make my model more robust and less prone to overfitting. Which options will help? Increasing alpha strengthens the penalty in ridge regression. This is a good idea. It makes the model simpler and less prone to memorizing the training data. Lowering alpha reduces the penalty, and my model will likely overfit the training data more because it will become less constrained, losing generalization capability. That's not what I want. Adding more features without careful consideration makes the model more complex, increasing the chances of overfitting. I should be more careful about which features I select. Cross-validation is an excellent technique to prevent overfitting. It helps to find the best value of alpha. By testing my model on different subsets of the data, I can find the alpha value that generalizes best to unseen data. This is crucial.